Okay, so in the last video, I was showing you some of these rules of matrix multiplication where in general, the product of A into B does not have to equal the product of B into A. So in the last example, this was the case because we saw that the product of A into B was defined because the number of columns in A was equal to the number of rows in B, but the product of B into A was undefined, right? This was just for the last example. Okay, but even if the products of A and B and A are defined, it does not necessarily mean they have to be equal. Okay, so let me show you an example in the textbook. So the example in the textbook is 15.4.4. And in that example, you have these two matrices which are given to you. So you have the matrix A. Matrix A is given as 2, 0, 0, 3. And the matrix B is given as 0, 1, 1, 0. Okay. So notice that both these matrices are 2 into 2, 2 into 2. So if you're doing A into B, the number of columns into A of A equals the number of rows into B. So that means A into B is defined, right? So A into B, the product of A into B is defined. But suppose you're doing B into A. The number of columns in B equals the number of rows in A. So that means the product of B and A is also defined. But when you do A into B, you'll see that the matrix you get is not the same as the matrix you do get when you do B into A. So, okay, so let's do A into B first, okay? So what is A into B? Remember, it's 2 into 0 plus 0 into 1, 2 into 1 plus 0 into 0, okay? And then 0 into 0 plus 3 into 1, 0 into 1 plus 3 into 0. So if you solve this, the matrix you're going to get is 0, 2, 3, 0. So this is your matrix C. Okay, so that means when you do N to B, you have a product C which is defined. But what happens if you do B into A, right? So if I do B into A, so now I have to write my B matrix first. So your B matrix was 0, 1, 1, 0, and your matrix A was 2, 0, 0, 3, right? So okay, now let's try to find B into A. What do you get? 0 into 2 plus 1 into 0, 0 into 0 plus 1 into 3, 1 into 2 plus 0 into 0, 1 into 0 plus 0 into 3. So what is the result here when you do B into A? So when you do into B into A, you get 0, 3, 2, 0. So you get 0, 3, 2, 0. So the result of B into A, let's make this the matrix D. Notice it's 0, 3, 2, 0. Whereas in the last, when we were doing A into B, what did we find? We found 0, 2, 3, 0. So A into B is not equal to B into A, right? So even though we had both the products of A and B and A defined, it's not generally true that these two, the resulting matrices, when you do these multiplication, they don't have to be the same. So there are some rules of matrix multiplication which you can review. Okay, so this is some more rules. So these rules are given in page 593. So I'll just write them down. You can review them. So the first rule says ABC equals to ABC. What does this rule mean? Suppose you have these three matrices, you multiply A into B, you get a matrix, and you multiply it into C. This is the same as if you multiply matrix B and C, and then you're multiplying this to matrix A. So notice something here. So what this essentially means is, notice that the order of multiplication is the same, right? So you're doing A, B into C. Over here, you're taking matrix A and multiplying it into B into C. So I'm not switching any of the orders of operation, which I was doing here. So that's why this is identical to this, okay? But over here, I was doing A into B, but in this side, I was doing B into A. Over here, I'm just finding this first and then multiplying it by this. It's the same as taking A and then multiplying into B into C. So none of the orders are changing. So this rule is true. The second rule is so if you add matrix B plus, so if you have matrix A and you're multiplying it to the addition of matrix B plus C, this is the same as multiplying A to B plus A to C, okay? Then rule C says A plus B into C is the same as AC plus BC. So if you add the two matrices A plus B together and multiply it to C, it's the same as if you multiply matrix A to C plus matrix B to C. And then the fourth rule is, if you have a scalar alpha into A and then you're multiplying this to the matrix B, this is the same as the A alpha B. And this is the same as alpha AB. Okay, so if you have a scalar, you're multiplying it to A and then you're taking the result and multiplying it to B. This is the same as taking matrix A and then multiplying this to the result of the scalar being multiplied to B. And this is also identical to multiplying A into B and then taking the scalar and multiplying it to the resulting matrix A into B. Okay, so these are some rules which you should review. Okay.